3 empirical formulas. Figure out the name and the compound, please. So these are the ratios in the empirical formula. Figure out how we would write that compound and name it.
I'm not ready for the
This is already the empirical formula. All I'm asking you to do is figure out what the compound is and name it. It is. Remember, if you're going to put a number by a polyatomic, what do you need to do to a polyatomic? What's that? Okay, well, ask yourself this, in that first one, go to your first one. Which part of that is the polyatomic? Okay, so,
Excuse me.
okay. Okay, so put those two together.
Wait, I need to do a charge thing.
Oh,
I mean, I'm just, what is,
what's the charge on which? What's the charge on which?
and then, like, times, code for this, because this is not 2.
correct because I forgot, whenever you put a order on my polyatomic, you have to do the polyatomic.
Right off.
Yeah.
Oh,
Parentheses around the polyatomic.
okay, thank you.
You're welcome. Please.
Shut up. Sounds good.
Are we ready, ladies and gentlemen? Okay. Well, let's begin with this, ladies and gentlemen. And I don't know, maybe we did this yesterday. Did we look at all of the polyatomics on the back of your sheet yesterday? Take a look at all of the push it, it's open, Katie. Take a look at the polyatomics on the back of your sheet, ladies and gentlemen. Every one of them, except for one, has what in common? Every single one of them, except for one, has what in common? No, that is not true. There are about 3 or 4 on the back that do not have oxygen. Ferrocyanide, ferric cyanide, and ammonium. That's 3. So what is unique about one of them on the back? And actually there's a couple things, but I'm looking for one specifically. But if you give me the wrong one, that's okay, as long as it's unique. What? What about hydroxide? So does cyanate, I believe. Natalie.
Ammonia is the only one with a positive.
That is one of the unique ones. And ammonium is one of the only one on the back with a positive charge. That is one. Now there is one other that is unique on the back. Absolutely correct. There is one other. And that one even goes along with this other rule, even though it's positive. Look very carefully at all of your formulas. All of the formulas, NH4, CO3, SO4, NO3. What do all of the formulas have in common? Except for what?
Most of them all have oxygen.
True, but again, I can name you 3 that do not. But you are correct. Most of them have oxygen in them, but I can name you 3 that don't. There is only one on the back that when you look at the formula, it is different from every other formula in some way. What? No. No. No one can find the one formula that is different from all of the others, Natalie?
Silicate has a negative culture.
Native what?
Negative one.
Okay, but, well, okay. But look at the formulas, not the charges, not the names. There is one formula that is different than all of the others.
Acetate?
Nope.
Manganese?
What?
Manganese?
Why?
Because it's all in
No, no. And there's only nitrate with an N, right? I know, but again, that may be true, but that's not what I'm looking for.
But manganese's the correct one?
Nope. Check out oxalate. What is different about oxalate from every other formula there?
It's not reduced.
It is the only polyatomic on the back of your sheet that is not written in lowest terms. Otherwise, every polyatomic on the back of your sheet is written in lowest terms, correct? Even ammonium, which as Natalie pointed out, is the only positive one. Absolutely. But that one is still written in lowest terms. That will help you here, ladies and gentlemen. That will help you here. So let's take a look at number 1. Now, which part of this is the polyatomic? Which part of this compound is involved in your polyatomic? The O and the H. The O and the H are involved in your polyatomic, absolutely. Not the magnesium. The magnesium is the metal, right? Okay. So the O and the H have to be part of your polyatomic. Have to be. All right? Oops. Oh, come on. Okay, so the O and the H are part of your polyatomic here, ladies and gentlemen. All right. Are they in lowest terms? No. So let's write them in lowest terms. What would O2H2 be in lowest terms? So that is the polyatomic that has to be involved, ladies and gentlemen. Okay? That is the polyatomic that has to be involved. Now, what element is it with? Magnesium. So now that we know this, ladies and gentlemen, what's the charge of magnesium? What is the charge of hydroxide? So when we write the compound, we get Mg OH 2, which means there is your ratio, ladies and gentlemen. 1 magnesium, 2 oxygen, 2 hydrogen. So once you figure out what your polyatomic is in this ratio, reduce it to lowest terms to find your polyatomic. Reduce it to lowest terms. Then you know what the polyatomic is. You know what the charge of the metal is. You now know what the charge of the polyatomic is now that you figured it out. Crisscross and write a correct formula. Now again, this is the one where people forget to put parentheses around the OH. Why? Because there's no number after the hydrogen. SO4, you realize, okay, it's probably not good for me to put a 2 next to a 4 because that makes it 42. So you're like, okay, let's put it in parentheses. This needs parentheses. Every polyatomic ion that you write, if you are going to put a number by it, has to be in parentheses, whether there is a number after the last element or not. Questions? So what is the name of this?
Magnesium.
Perfect. Perfect. All right. So let's take a look at the next one, ladies and gentlemen. So what part of this compound is your polyatomic again? What part is the polyatomic? The C and the O. Okay, aluminum is with it, so the C and the O is part of the polyatomic. C1.5, O 4.5. What does that reduce to? Even though they're both 0.5s, we can still reduce these. What does that reduce to? CO3. There's your polyatomic, ladies and gentlemen. There is your polyatomic. Now, what is the charge of CO3? -2. Aluminum has a charge of what? +3. So if we were to write the formula for this compound, what would it be? And that's how we get to this, because this is Al2C3O9. We cut these in half. We get 1, 1.5, 4.5. That is your formula there. That is your empirical formula. Now, why do you get that? Because remember, when we do convert to mole, after we get everything into moles, what do we do to the numbers that we get? And that guarantees you of getting a 1 in here. That guarantees you of getting a 1. So when this is 1, this is 1.5, this is 4.5. Now granted, we would have to double this, correct? When we do, we get the 2, the 3, and the 9 that is in this formula. So it works out. Why? Because it's all about ratios. It is all about ratios. Now, we've just given you the easiest way to find your polyatomic. Because your polyatomic, ladies and gentlemen, is the 2 elements that are not the metal, okay, or not the first one normally. Occasionally you may have ammonium. That would be the first 2. That would be nitrogen and sulfur, right? Or nitrogen and hydrogen, correct? So it is possible that your polyatomic could be at the start, but most of the time it's going to be at the end. And again, we find it in lowest terms, then we're able to work the problem out. Questions? All right. We're going to skip through everything. Can someone give me the name and the formula for this compound written correctly? Zinc, night, what's the ending? Just so I thank you very much. Formula? What was it? Like that? That's better. Okay? That gives us our 2 nitrogen and our 4 oxygen. But again, here's your polyatomic, ladies and gentlemen, N2O4, which when we reduce it becomes NO2. That is nitrite, ladies and gentlemen. So again, we are finding the elements that are in our polyatomic. We are putting our polyatomic in lowest terms, then we are writing the compound with that polyatomic. That is what you will do to find those formulas. Questions? 1. Oh, now we're over budget. First question on your test. Doing 3 of these. Finding the formula, writing the name. Questions? Okay. Today, ladies and gentlemen, I want to do a couple of things with you just to finish some stuff up. So if you would take out your computers, sorry, I guess you are going to need them today. This is where we left off the other day. So while you're getting your computer out, while it is starting up, let's take a look at this. Okay? And again, this goes back to your pink sheet. Looking at a compound and determining what one of 2 outcomes there are for any compound that is created in a chemical reaction. By the way, it's been a long time since we've done them. But there are 4 basic kinds of chemical reactions: synthesis, decomposition, single replacement, and double replacement. Okay? Now, I do not expect you to know how to predict a synthesis or a decomposition reaction. That I do not expect you to know how to do. I do expect you to know how to do a single replacement and a double replacement. Now, you're not going to need it for a little while yet, but we are going over some things here. In both a single and double replacement reaction, you will have either 1 or 2 compounds. Single replacement, 1 compound and a lone element. Double replacement, 2 compounds. The compounds in the beginning of a single or double replacement reaction are always aqueous. They have to be aqueous. If not, they have already reacted. If they were a precipitate, no reaction would happen because a precipitate will not react. So what that means, ladies and gentlemen, is any compound that is written before the arrow will actually be aqueous and will actually do this. It will literally break apart into the ions that make it up. So silver nitrate breaks apart into silver and nitrate ions. Now, the way we express ions is we have to put a charge after them. Because what this is telling us is that this silver has lost an electron, and it is a +1 charge. This nitrate has gained an electron, and it is a it is a -1 charge. And they are both aqueous. If something is in parentheses, that number outside of the parentheses goes in front of that ion to balance off how many ions there are. So this 2 that is here around the ClO3 goes in front of it if you're breaking it apart into ions. Lead would be a +2, chlorate would be a -1, and there's 2 chlorates that are -1s to balance off the lead that is a +2. Questions? Now, how do I know lead chlorate is aqueous? Well, up here is chlorate. Chlorate is in the section of our sheet where anything that we put with it is going to be aqueous. Chlorate is one of the compounds, the two compounds, that no matter what you put it with, it will always be aqueous. So whatever you put chlorate with, it's going to be aqueous. For sodium phosphate, here's phosphate. Phosphate is normally a precipitate. It is normally a solid, unless it is with the cations of group 1 or ammonium, except lithium. So is sodium in group 1 of the periodic table? Absolutely, right there in group 1. That means that the exception is that this will be aqueous in water. It will break apart into the ions that make it up. Now, notice the 3 by the Na comes out in front, so that we have 3 Nas balancing off this one PO4 group that is a -3 charge. Does anyone have any questions? If we put aluminum with sulfate, here's sulfate, SO4. It is in the part of the charts where it is normally aqueous. Normally it will dissolve in water, unless you happen to put it with silver, lead, barium, strontium, or calcium. Aluminum isn't any of those. Therefore, it is aqueous. Therefore, it will break apart into the ions that make it up. The 2 here goes in front of the aluminum to tell you there are 2 + 3 ions. 2 + 3 equals plus what? Don't look at me like I'm crazy. I'm asking you a simple math question. 2 + 3s equals what? +6. Here we have 3 SO4s that are a -2. The 3 outside goes in front. 3 -2s equals -6. +6 and -6 equals, that is what the total charge on any compound is. That is why we put the 2 here and the 3 here, to get a total charge of 0. Questions? Okay. So, if we talk about ionic equations, ladies and gentlemen, an ionic equation is when you have either a single replacement or a double replacement. And you have ionic compounds in them. Those that we were just showing you are ionic compounds. Okay? Those are ionic compounds. So, aqueous magnesium chloride is mixed with aqueous silver nitrate and will react in a double replacement reaction. Predict the products and write a balanced chemical equation, then create a net ionic equation. Again, I am just showing this to you to get ahead. Okay? Understand, this is not on your test. Okay? So, we are going to do what is called a skeleton equation. This is magnesium chloride, MgCl2. Magnesium a +2, chlorine a -1. We have written a good compound here. Does everyone agree on that? This is silver nitrate. Silver is a +1, nitrate is a -1. AgNO3 is your good compound. Any questions on that? Now, in a double replacement reaction, the 2 metals that begin the reaction switch places. Switch what they are with. So magnesium is going to switch place with silver. Magnesium will then be with nitrate. Silver will then be with chlorine. Now, people always ask, what happened to the 2 by the chlorine here? Well, we need to write a good compound. What is the charge of silver? +1. What is the charge of chlorine? -1. Those cancel each other out, right? The reason for the 2 here was that magnesium was a +2. Now chlorine is with something that is a +1. This is a good formula. Okay? Our other formula is magnesium +2 with nitrate -1. So now I need 2 of the nitrates to balance off the +2 of the magnesium. Any questions about how I got these formulas? Always writing a good individual formula. Now I come up to this sheet. To know if this reaction actually happens, I need to find one of 3 things. I need to find water. Is water a product here? No, neither of these is H2O. Is either of these a gas? What would tell you they are a gas? The S. What would tell you they are a gas? What would you put by a gas? A G. Is there a G here? No gas then. The third thing that could tell you this reaction happens is you can find a precipitate. That is where we use this table. Okay? That is where we use this table. So we have 2 products. Silver chloride, magnesium nitrate. Well, what do we know about nitrate? Never precipitates. So that's got to be aqueous. So now we look for silver chloride. We come up here. Here's chlorine. Normally it is aqueous unless it is with what? Silver, lead, or mercury. And guess what? So it's a precipitate. That means this reaction will actually happen. Now, the next step we would do, now that we know the reaction actually happens, is we would balance it. Now again, for some of you it has been only a few weeks since we have done this. For some of you it has been a few months. So to balance, ladies and gentlemen, to balance this out, I am going to take and I'm going to create what I call a scoreboard. The scoreboard goes right underneath the arrow symbol. And the scoreboard lists all of the different things that are in this compound. So it is Mg, Cl, Ag, and I'm going to do a little trick here. I'm going to leave NO3 together. Now, if you do not like this trick, you could easily separate this to N and to O. The only reason I am leaving it together is because it's NO3 here and it's NO3 over here. It's always together, same ratio. I'm going to treat it as a group. Questions? How many magnesium are on the reactant side before the arrow, Claire? How many magnesiums are there? 1. Perfect. How many on the product side, Claire? 1. How many chlorines on the reactant side, Elsa? Before the arrow, how many chlorines? 2. Thank you. How many after the arrow, Elsa? After the arrow, Elsa, sorry. Thank you. How many silvers are there before the arrow here, Paola? And after the arrow? 1. How many nitrate groups, Jalen? Groups. Before the arrow, 1. How many after? Good. Excellent. Now, please remember, no parentheses around the group means there's only one of them. Okay? You don't like this, you could break it up into nitrogens and oxygens. There would be 1 nitrogen on this side, 2 on this side. There'd be 3 oxygens over here. There would be 6 over here. You could do it that way. Now we are going to balance it. Balance means I am going to put these coefficients, these big numbers in front, that are going to change the amount of them there so that we can get it balanced. Okay? So, the 2 things that are not balanced, that are not the same on both sides, are what and what? Alicio.
What's the question?
What are the 2 things down here that are not the same on both sides?
Chlorine
Chlorine and this nitrate group. Now, the reason I do this under the arrow, ladies and gentlemen, so that I can keep track side to side. Chlorine has more chlorine on the reactant side than it does on the product. But there is more NO3 groups on the product side than there are on the reactant. I have to make this balance. So, I'm going to start with chlorine. I've got 2 chlorines over here. What number do I put in front here to make 2 chlorines? A 2. I put a 2 in front. Now, unfortunately, ladies and gentlemen, that does give me 2 chlorines, but what else changed? The silver, so I have to put a 2 by it. The entire compound changes. There's 2 of them now. Okay. The next thing I need to balance is the nitrate or the silver. Either one. Got to get everything balanced. So, originally there are 2 nitrate groups on the product side. What number do I put in front of AgNO3 here to get to 2 nitrates? And it does make it 2 nitrates, but it also makes it 2 silver. And everything balances. Okay? Everything balances. That is our short, quick review on balancing, ladies and gentlemen. Okay? Questions on that? Now, what you're looking at here is something similar to what you will see in Unit 7. Okay? We still got to get through Unit 6 first, but that's where it's coming. So we will review a little bit in Unit 6 so that when we get to Unit 7, hopefully we are good with this. Questions? Okay. So now I want to show you this part up here where it talked about predict the products, write a balanced chemical equation, and then create an ionic equation. All right. So we found our precipitate. There it is balanced. All I did was balance it just like we did, but here's what you get. Any questions? Okay. We are now going to take this and write what is called the net ionic equation. What that means, ladies and gentlemen, is anything that breaks apart. Let me rephrase that. Go back. Anything that is aqueous will break apart when you put it into water. Let me show you what that looks like. All this is that same equation on the next slide written out and balanced for you. Okay? This compound, because it is aqueous, will break apart into magnesium ions and chlorine ions. 1 magnesium, 2 chlorines. Any questions there? Now, I know normally we don't write ones here, correct? I'm just showing that to you so you can see that there is one of them. And there is one of these here. Questions? This is aqueous, so this is also going to break apart. But we need to account for the 2 in front here. So it breaks apart into 2 silver ions and 2 nitrate ions. Because of the 2 in front, there are 2 of these and 2 of these. Questions on that? Okay. Arrow symbol. This is a precipitate. What does a precipitate mean? What is the definition of a precipitate? You're close, not a liquid. A solid that settles out of solution. Meaning, if we put this into water, ladies and gentlemen, it doesn't change. It's the solid. It is the thing that does not change. But this is aqueous, which means what? And? Nope, not settle out. It's going to break apart into the ions that make it up. So it's going to break apart into a magnesium ion and 2 nitrate ions. Questions on this? Okay. Now some of you have probably heard this story because you had me last try. Some of you haven't. Okay? When I was a kid, I hated reading. Hated reading. Still not a big fan of reading. but for somehow they put me in an accelerated reading program, right? So I had to read extra books when I was in school. I didn't like reading books to begin with, okay? So I developed two good skills that I had in school. Number one, if I had to do a book report, I picked a book that they made a movie out of. So I could watch the movie instead of reading the book, okay? That was my first one. But my second one was when you had to go to these accelerated reading and you had to discuss the book, I never spoke first. I never spoke first. Madison would go and she would be like, Johnny in this book was such a tortured character. He didn't know what end was up and what to do, and I always went second. I agree completely with Madison. That Johnny character, he never kind of got his feet under, and I would just restate what she said and I wouldn't get called on again the whole time. Okay? Wouldn't get called on again the whole time. So the other day I met with Mrs. Lipp and I was telling her the story, how I was telling my class this. And the next meeting that I went to with her, she gives us a book we got to read. I said, okay, when we start discussing this, I get to go second. Okay? So now I got to read a book. Not thrilled. Point being, ladies and gentlemen, if I couldn't find a book that they made a movie on, I had one last hope. It was called Cliff Notes. You guys know what Cliff Notes are?
No.
Today they're called Spark Notes. And they take a book that is this thick and tell you a synopsis of it that is that thick. And I would read that and I could do a book report off of it because it was less reading, right? But it just kind of took out some of the stuff you didn't need to know and got down to the basics. Let's do that with this reaction. There's a lot of things going on here, aren't there? But what do you notice about magnesium here and here? It's the exact same way, isn't it?
Yeah.
If we were to treat this arrow as an equal sign in math, and you have +6 on one side of an equation and +6 on the other, what do you do to that? You cancel it. Guess what? We're going to do that here. We're going to cross off what are called the spectator ions, the things that don't get involved. Magnesium is 1. What's the other one? The NO3. So in reality, ladies and gentlemen, this entire reaction comes down to this. Chlorine ions combined with silver ions to make silver chloride. That's the spark notes of this reaction, ladies and gentlemen. That is it boiled down into the lowest possible explanation. That is what that whole reaction amounts to. The magnesium and the nitrate are just floating around in water at the beginning, and guess what? They're just floating around in water at the end. They don't actually do anything. Okay? That's the spark notes. Questions? This will not be on your test. Okay, here's what's going to be on the test for the third time. Number 1, first question. You're going to get 3 empirical formulas. You have to translate them into the actual formula and the name like we did at the start of class. There will be 4 two-step conversions. Those are on the right-hand side of the table in the back for you to practice. Then there will be 3 problems that make up 42 points out of the 70 points on your test. 42 out of 70. That is 60% for those of you who are not good at math. So you can pass the test on 3 problems. 1 is find an empirical formula. 1 is find a molecular formula. 1 is find the percent composition. Now over on this side of the room, in the back corner on this side of the table, in the middle, are just empirical formula problems, and on the front there's still those others where it has a molecular formula, an empirical formula, and a percent composition. Questions? I'm done talking. Go start reviewing. What you need help with, raise your hand and call me over. You got today and tomorrow to get help from me if you need it, because when you walk in the door on Friday, we are starting the test right away. Any notes that you need to add to your periodic table, any notes that you need to add to that pink sheet, today and tomorrow, get them done. And if you have any questions whatsoever, raise your hand, call me over, and I will give you assistance. If you're working on problems out of the packet, absolutely okay. Those answers are in your EISN. There are answer keys for everything back there.